if you weren't here for the lab, we went over how to do naming, and so I'm going to add some stuff to the video I made. So what I did was I pointed out that ides are for the periodic table substances, and eights and ites are here. So if I see carbonate, carbonate is here. So I'm going to copy, and that's the second thing, and then it goes here, and then it goes here. So we have this piece that's going all the way through. When you get to the end, there's no charges, so we're going to delete that charge. The sodium is in the first column, so it's 1 plus. And so that needs to go here, Na 1 plus. And so, sorry, thinking at the same time. So here what I want is 2 minus is my largest value, and I need this to balance that out with 2 plus. Now, it's absolutely possible for it to be 4 plus and 4 minus, or 6 plus and 6 minus. But in this case, it'll be 2 minuses, which you can see here. I already have my 2 minus. But I only have a 1 plus. And so what I'll need to do is add another one. So I'm going to add another sodium here. And you can just do it by copying and pasting if you want to, or you can type it out. And now you have a balanced set of charges, and you add an Na lowercase control comma 2. So I have 2 NAs and I have 1 CO3. So these two, that 2 means 2 BRs, that 2 means 2 NAs, and the CO3 stayed together. I'm going to skip down here so this video isn't too long. The Fe is here. There's a nitrate here. Copy, paste. Another one here, another one here. We don't need charge. Now, for transition metals, you'll see a Roman numeral, and that Roman numeral means +1 in this case, and 3 plus in this case. So I need to put a 3 plus here, and then transfer my Fe 3 plus to here. So control period to go up, copy that, paste it. And again, my largest number is 3 plus, so I need a 3 minus. It could also be 6 minus or 9 minus, depending on the ions I have. But this will work perfect because this represents a single minus charge. Copy, paste, paste. So now I have, now I have 3 minuses. So I'm really only paying attention to this negative charge here. So there are 3 negatives to match up with my 3 positives. It is common for students to look at that 3 and see it as relating to or multiplying by the 1 minus, and it's not. It just stays in the molecule the whole time. Okay. So that means I have 3 of these. 3. And so you see it. I'm going to do that, and I'll change this color. So that 3 right there tells me how many I have. There's only 1 Fe. And in order to separate these 2 3s, we use parentheses. So there's a parentheses, and there's a parentheses. So now it says 3 NO3s. So that means I have an Fe, and then I have N, and I have another one, and I have another one. So that means I have NO3 3 times. All right, well, we need to use that for this problem. So in this problem, you start with these two names. And your job is to make new names on the other side. Not the same names, but new names. So we're going to get rid of this, and we're going to put the nitrate there. So this nitrate, which was on this side, ends up now being on this side with the sodium. And this carbonate, which was with sodium, will now go with silver. So I'm switching those around. We usually say we're switching the metals, but it doesn't matter. We're just trying to create a new set of partners for this. So now we just do what we go through all the steps of finding, we go through all the steps leading to the compound. And so in this case, they're the same. And in this case, I need one more Na so that my charges are balanced. So I have two 1 pluses and I have 2 minus. Okay, this is one side. Then you do an arrow. And now you put this together. But what's nice about this is you already know what all the charges are. So I know that sodium is 1 plus because I already wrote it. I know that nitrate is already 3 minus. So you've already done all the charges. And so you know about all, like you've done all the brain work. Now you just have to repeat what you've done before. So here, a 2 and a 1, I'll need a new Ag 1 plus, so I'll do that. And so now I have 2 Ags and a CO3. Okay, that's what I need you to write inside all of these boxes. So for the next boxes, that's what you're going to write. So let's go down to the next one. And so this should be B. Sorry, let's get rid of this. There, now it says B. So I have my silver, my iron nitrate, and then on this side, let's bring that up a little higher. And then on the product side, the iron 3 will be with hydroxide. And the barium will be with nitrate. So I've taken the nitrate that was here and combined it with barium, and at the same time combine the iron with the hydroxide. So go through all the steps again. I have Fe 3 plus, NO3 1 minus. Well, I'll need more of those. Looks like I didn't give myself enough room. And then I have a barium. Now barium is on the periodic table, so chloride will be on the periodic table because it says "ide." Barium will have a charge on the periodic table. It's in the second row, so it's +2. And hydroxide is in the polyatomic ion chart that was at the top of the page where we were working before. That's 1 minus. Okay, so when we put this together, change color so you can see we did this up above. You use parentheses to show you have more than one. And then you do barium, and you have more than one hydroxide, so it looks like that. And now you're switching, but we already know what they are. Let me try something else. So this is going to show up again here, right? Because they're the same thing. Or scribble. And so now I have iron 3 again, but this time it's with hydroxide, but it's also 1 minus. And you're going to get a compound here with my hydroxide in parentheses. We're not going to do the whole thing, sorry. And then you still have barium. Nothing's changed about the barium. It's still 2 plus. And nothing's changed about the nitrate. It's still 3 minus. So here, this nitrate and this nitrate are the same thing. We don't mess with it. And so now we're going to have nitrate. And there's going to be a certain number. So there's going to be a number here, and there's going to be a number here. The barium will go here, the iron will go here, and then you just have to figure out what is that number that goes there, and what is the number that goes there. And so that's how you do this part of the lab. Okay, and lastly, there are rules on this side for not forming a precipitate. This is the solid. So in the lab you made something, and that was a solid, and sometimes you didn't make something. So one of these will follow these rules, and one of these will follow these rules, and whichever one follows these rules, right here, this forms a solid. And that's what this question is asking. Which of these forms a solid? So you go through the rules. If it's one of these rules, you go, oh, it's that one, and you put it here. If it's one of these, then it can't be that substance. So anything that has a metal, has a nitrate, for example. Anything that has a nitrate can't be the answer because it doesn't form a solid. Anything that has a carbonate, sorry, I'm just telling you the answer. Anything that has a carbonate would have to be the answer because this is the side that makes the solids. All right. For people who stayed at home, that's some of the questions you might have asked me from the lab. So I'm hoping this will help. And sorry it's so long. Bye.